Assalamu alaikum. Now moving to the next lecture, we are going to continue with central forces. As previously we have discussed about the central forces origin and the polar coordinates to describe the central forces. You know that central forces are those forces which act towards the origin or out of the region, as all the particles inside a system are bounded. All the particles are bounded to act their forces towards the origin or out of the origin. Now moving further to the equation of central forces to find from the equation of motion of central force. The second equation we have to find is d square u over d theta square plus capital U, that is for potential, is equal to minus m over L square u square into F into 1 over u. Here we know that u is equal to 1 over r. This equation of motion for central field of force is derived in terms of variable u is equal to 1 over r. We know that the basic equation of motion for the central force is given as m into r double dot minus r theta dot square, that is equal to f of r. That equation is previously derived, and that is the radial component of force, m into r double dot minus r theta dot square. Here acceleration is in the central force form is written as r double dot minus r theta dot square, that is the radial component of acceleration multiplied by the mass, and that gives the central force, that is f of r. Now multiplying that m inside the equation, we get mr double dot minus mr theta dot square is equal to f of r. Substituting that equation number 1, from that equation we have to find out the value for r double dot, that is the acceleration, and you know that acceleration is second differential of position vector with respect to time, that is d square r over dt square, that is represented in r double dot, so that is mr double dot. Then we have to find the value of mr theta dot square. Here we know that u is equal to 1 over r. From here we will find the value of r, that is r is equal to 1 over u. Then we have to find the differential of r, so we will take the differential d by dt into r. You know that the first differential of position vector r is represented by r dot is equal to d by dt into 1 over u. Now applying the chain rule, we have r dot is equal to d by d theta into 1 over u into d theta by dt. Here we have multiplied and divided by d theta and rearranged the equation. That becomes d by d theta, as we have to work out with the differential of d theta in the last equation. So here is d by d theta into 1 over u d theta by dt. You know that first differential is represented by dot, so here d theta by dt is theta dot. So replacing d theta by dt with theta dot, we get r is equal to theta dot into d by d theta into 1 over u. Now here again uh, 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 differentiating 1 by u with respect to theta, we have minus 1 over u square into du over d theta. Giving that equation number 2, and substituting the value for theta dot, and here that equation r dot is equal to theta dot into minus 1 over u square du over d theta bracket close is given the equation number 2. We know that theta dot value can be worked out. So for that we can use the value of angular momentum L, that is mr square theta dot. Now substituting the value for theta dot from angular momentum value L is equal to mr square theta dot, we have theta dot is equal to L over mr square. We know that u is equal to 1 over r and u square will be equal to 1 over r square. So substituting the value of 1 over r square is equal to u square in place of 1 over r square, we get the value for theta dot is equal to L over m into u square, and rearranging the equation we get Lu square over m. Now substituting that value in equation 2 we get in place of theta dot r dot is equal to Lu square over m into minus 1 over u square du over d theta. Cancelling u square above and below, we are remained with the value r dot is equal to L over m into minus du over d theta. Now from here the remaining equation is r dot is equal to minus L over m du over d theta, giving that equation number 3. Now we have to find the value of r double dot, so we have to differentiate the r dot value in equation 3 again with respect to time. So we know that if we take differential with respect to time of r dot, that will give the second differential of r, so that will become r double dot on left hand side, and that will be equal to minus L over m into d by dt, as differential has to be taken on both sides. So on the left hand side that d by dt made r dot r double dot, and on the right hand side we have minus L over m d by dt into du over d theta. Now again applying the chain rule, as we need the value of du over d theta, so multiplying and dividing by d theta and rearranging, we get r double dot is equal to minus L over m into d over d theta into du over d theta into d theta by dt. So that d theta by dt, you know, that will give the first differential of theta, so that will become theta dot, and again substituting the value for theta dot, and we get the value from here. We have the equation r double dot is equal to minus L over m theta dot d by d theta into du over d theta bracket close. As we know that u is equal to 1 over r and u square is equal to 1 over r square, and we know that the value of theta dot is L over m into 1 over r square. Substituting the value for 1 over r square, we get L over m into u square, and from here the equation will become L u square over m. Squaring both sides, we get theta dot square is equal to L over m u power 4. So substituting the value for theta dot, we have r double dot minus L over m into Lu square over m d square u over d theta square, and that equation gives r double dot is equal to minus L square u square over m square into d square u over d theta square, and that gives the equation number 4. Putting the value of r double dot from equation 4 in equation 1 previously mentioned, and putting the value of theta dot and value of r is equal to 1 over u, as we have the equation mr double dot minus mr theta dot square is equal to f of r. That is equation number 1. Now substituting the value of r double dot and the value of r and the value of theta dot square, that is L square u power 4 over m power 2. So that is m into minus L square u square over m square d square theta d square u over d theta square minus m into 1 over u, as in the place of r we have substituted 1 over u, and in the place of theta dot square we substituted the value L square u power 4 over m square is equal to f of r. In place of r we substituted f of 1 over u, and cancelling m on left hand side in the first term m with m, we are remained with 1 m in the denominator, and on the right hand side in the second term we cancelled m with m in the denominator and u with u. So the equation left will be written as that gives minus L square u square over m d square u over d theta square minus L square u cube over m is equal to f of 1 over u. Now taking the common minus L square u square over m, we get minus L square u square over m into d square u over d theta square minus is changed into plus into u, as u cube, it was u cube, so that is remained with u, as u square is common on the outside, is equal to f of 1 over u. Multiplying and divide both sides with minus m over L square u square to cancel the term on the left hand side to make the equation as required to be proved. So we have minus L square u square over m square minus L square u square over m cross minus m over L square u square into d square u over d theta square plus u bracket close is equal to minus m over L square u square into f of 1 over u, cancelling minus L square u square over m with minus m over L square u square. We are remained with the equation which we have to derive is d square u over d theta square plus u is equal to minus m over L square u square into f of 1 over u bracket close. That is we give the equation number 5. Now moving to the next equation, we have to derive for the central force by using the equation of motion is in the terms of energy and potential energy. All the three equations are derived by using the equation of motion of the central force, that is f of r is equal to m into r double dot minus r theta dot square. Now the third equation is conversion of energy in central field of force and deduction of the following equation of motion, that is d square u over d theta whole square plus u square is equal to 2m into E minus V over L square. Here capital E is the energy, total energy, and V is the potential energy. Now let the energy E is the total energy and V is the potential energy of the particle. To prove the conservation of energy, In central field of force, we make the use of the following equation. That equation I already told you of central force. That is m into r double dot minus r theta dot square is equal to f of r, or by multiplying the m inside the equation we get mr double dot minus mr theta dot square is equal to f of r, and giving that equation number 1, we know that central force is the radial component that acts along the line where all the forces act along the origin in the central force, and r double dot minus r theta dot square is the radial component of acceleration, that is similar to the equation of Newton's second law, that is F is equal to ma. Here that is the equation of force for the central force of field. Now we know that L is equal to mr square theta dot, that is the angular momentum value. From here we substitute the value of theta dot is equal to L over mr square. So taking that value of theta dot, we substitute that value of theta dot in equation 1. We get mr double dot minus mr into L over mr square whole square is equal to f of r. Opening the square of L over mr square, we get mr double dot minus mr into L square over m square r power 4, cancelling the m in above and below in the second term we get, and cancelling one r above and below with the r power 4, and we are remained with the equation mr double dot minus L square over mr cube is equal to f of r. Taking the term on the left hand side of is equal to of minus L square over mr cube on the right hand side, that minus term is converted into plus, so that equation we get is mr double dot is equal to L square over mr cube plus f of r. Giving that equation number 2. Till here you have understood the process or steps we are doing. I give you here few seconds to note the steps so that you can understand all the steps we are going to work out for the final equation. Now moving to the next step, the equation will be used to get the desired result. If equation 5 is the scalar point function potential energy, then the central force will be equal to the radial component of grad V, or we can say that the force is equal to negative gradient of R. So that can be written as f of r is equal to minus dv over dr, giving that equation number 3. Also L square over mr cube, we have to find the value. So we are going to work out for the value L square over mr cube to make the differential form of L square over mr cube. From here we can see that L is constant, m is constant. Only 1 over r square can be converted to r cube if we take the differential of d over dr. So assuming that is a differential form of L square over mr cube is equal to d over dr into minus 1 by 2 L square over mr cube. Here you can see that if you work out that equation, get the desired result that L square over m is constant. If we take that constant outside and take the differential of 1 over r square, we are remained with the value minus 2 by 2 into 1 over r cube. That 2 by 2 is cancelled, then we are left with the value r cube. So, and the minus sign is cancelled with the minus sign of r square. So we have the value L square over m into r cube. That is the equation 4. Now putting that value from equation 3 and equation 4 in equation 2, we get mr double dot is equal to minus d over dr into 1 by 2 L square over mr square bracket close minus dv over dr. Here d by dr is constant, is common, so that can be taken out of the bracket. Then the equation is mr double dot is equal to minus d over dr into 1 by 2 L square over mr square plus v bracket close. Till here, if there is any difficulty, you can ask. I give you few seconds to note down the steps to understand. Then moving to the for next step, we have now multiplying that equation with d by dr over dt on both sides. We get mr double dot dr over dt is equal to minus d over dr into 1 over 2 L square over mr square plus v bracket close dr over dt. As we know that dr over dt on the left hand side is first differential r dot. So on the left hand side we have mr double dot r dot is equal to minus d over dr into 1 over 2 into L square over mr square plus v bracket close dr over dt. Here cancelling dr above and below, we have the equation mr double dot r dot is equal to minus d by dt into 1 over 2 L square over mr square plus v bracket close. Reviewing that equation number 5, take the left hand side of the equation from equation 5 and write its solution. So we can write as mr double dot r dot that is equal to d by dt into 1 over 2 mr dot square. From here if you work out, take the differential, we have mr dot 2 by 2 into mr dot into r double dot, that is the same equation we have required in the above equation. So for that the different solution of differential form for mr double dot r dot is d by dt into 1 over 2 mr dot square, giving that equation number 6. Putting this value from equation number 6 in equation number 5 on the left hand side, so the equation becomes d by dt into 1 over 2 mr dot square is equal to minus d by dt into 1 over 2 L square over mr square plus v That is the equation by putting the value of mr double dot r dot. Till here you can note down the steps. I give you few seconds to note it. So by substituting that value we get d by dt into 1 over 2 mr dot square bracket close is equal to minus d by dt into 1 over 2 l square mr square plus v. So d by dt into 1 over 2 mr dot square is plus d by dt into 1 over 2 l square over mr square plus v bracket close is equal to 0. We have taken the term from the right hand side to the left hand side, making the minus term the positive term. Now taking the common from the both terms as d by dt, we get d by dt into 1 over 2 mr dot square plus 1 over 2 l square over mr square plus v, that is equal to 0, giving that equation number 7. Now integrating both sides, we have 1 over 2 differential integration cancels, so we have the equation 1 over 2 mr dot square plus 1 over 2 l square over mr square plus v, and we know that by integrating that is equal to constant. We know that as angular momentum value L is equal to mr square double dot. I give you few seconds to understand and note down the steps to calculate the equation for the final result. Now substituting the value of L, we have 1 over 2 mr dot square plus 1 over 2 m square r power 4 theta dot square over mr square plus v is equal to constant, cancelling 1 m with 1 m and r square with r power 4. We left with the value 1 over 2 mr dot square plus 1 over 2 into mr square theta dot square plus 1 is equal to constant. So that equation becomes 1 over 2 mr dot square plus 1 over 2 mr square theta dot square plus v is equal to constant, giving that equation number 8. We know that mr square is equal to capital I, and that is moment of inertia. I is equal to mr square, and we know that theta dot means the angular velocity omega. So In above equation, we can replace mr square with capital I and theta dot with omega. So we have the equation 1 over 2 mr dot square plus 1 over 2 iota capital I for inertia into I omega square 1 over 2 I omega square plus V, that is equal to constant. Giving that equation number 9, we know that 1 over 2 I omega square is the rotational kinetic energy, and here r dot means the linear velocity dr over dt, that is equal to r dot. So we can see that 1 over 2 mr dot square means the 1 over 2 is similar like the equation 1 over 2 mv square. So 1 over 2 mv square means kinetic energy. So we can see that kinetic energy is in the two form, that is the rotational kinetic energy 1 over 2 I omega square and translational kinetic energy 1 over 2 mr square mr dot square, and plus with the potential energy V, that is equal to constant. It means that total kinetic energy and the sum of potential energy and kinetic energy remains constant, and here total energy is in the form of rotational, translational and potential. So here we can substitute 1 over 2 mr dot square is equal to 1 over 2 mv square is equal to kinetic energy, and V is potential energy. So the equation is left as kinetic energy plus rotational energy plus potential energy, and that is equal to constant. Giving that equation number 10, this shows that total energy in central field of force remains constant when the objects are in rotational motion, or we can say that it is conserved. Now considering the above equation, we know that total energy is sum of rotational energy, kinetic, translational energy and potential energy. So we can write from equation 8 1 over 2 mr dot square plus 1 over 2 mr square theta dot square plus V is equal to energy. So the equation is 1 over 2 mr square plus 1 over 2 mr square theta dot square. Taking the potential energy V on the right hand side, it changes into the negative sign. That gives E minus V on the right hand side of is equal to. From here, taking 1 over 2 common and m common, we have the value m over 2 into r dot square plus r square theta dot square bracket close is equal to E minus V, and taking that m by 2 cross multiplied on the right hand side, we get r dot square plus theta, r square theta dot square. M by 2 is converted into 2 by m, so that is equal to 2 into E minus V over m. I hope till here you have understood the steps. I give you few seconds to note down and understand the steps. Now putting the value of theta dot is equal to L over mr square, we have the value r dot square plus r square into L square over m square r square is equal to 2 over m into E minus V. Cancelling r square with r square on the left hand side in the second term, we have the remaining value, uh, that there is the r power 4 on the in the denominator. So cancelling r square with r square, we have left with the value r dot square plus L square over m square r square is equal to 2 by m into E minus V. Giving that equation number 11, but we know that r is equal to 1 over u. From here, if we take the differential of r, that is dr over dt, that will be equal to r dot, and d by dt is equal to d by dt into 1 over u. Similar as previously done, we will take the chain rule. By applying the chain rule, we know that on the right hand side we will multiply and divide by d theta. Rearranging the equation, we get r dot is equal to d by d theta into 1 over u d theta by dt. Here we know that d theta by dt is the first differential of theta, so that can be replaced or written as theta dot. You can note down the steps and understand the steps. Here I give you few seconds to note and understand these steps. We have the value r dot is equal to theta dot into minus 1 over u square into du over d theta. Here we have differentiated 1 over u with respect to d theta. So we have minus 1 over u square into du over d theta. So the equation is r dot is equal to theta dot into minus 1 over u square du over d theta. We know that angular momentum value is L is equal to mr square theta dot. From here we can get the value of theta dot, that is equal to theta dot is equal to L over mr square. So substituting that value, we have L r dot is equal to 1 L over mr square into minus 1 over u square into du over d theta. As we know that u is equal to 1 over r, so if squared both sides, we have 1 over r square is equal to u square. So in the equation theta dot is equal to L over mr square, we can write theta dot is equal to L over m into 1 over r square. So in the place of 1 over r square, we can substitute the value u square. So we have theta dot is equal to L u square over m. Now substituting that value, we get r dot is equal to L u square over m into minus 1 over u square into du over d theta. Cancelling u square with u square, we have r dot is equal to L over m into minus 1 into du over d theta. From here we get r dot is equal to minus L over m into du over d theta. Here till here we have found the value of r dot. Now we have again have to find the value of r dot. So I give you few seconds to note these steps and understand this. If there is any question, you can ask me. Now moving on the next step after few seconds. As we have to find the value of du over d theta whole square, we have to make the equation. So here we square the both sides with both sides, we get r dot square is equal to minus L over m whole square du over d theta whole square. So we have r dot square is equal to L square over m square into du over d theta whole square. Giving that equation number 12, we know that minus term is when squared, then that is equal to positive, converted into positive. So minus L square will be equal to positive minus L whole square will be equal to L square, positive L square. So we have the equation 12. Now we can use that equation of r dot square in the from the equation 12 in equation 11. We substitute that value, we have L square over m square into du over d theta whole square plus L square over m square into r square, L square over m square r square is equal to 2 into e minus v over m, and on in the place of 1 over r square in the second term, on the left hand side we substitute u square. So the equation becomes L square over m square into du over d theta whole square plus L square u square over m square is equal to 2 into e minus v over m. As we know that on the left hand side there is a common term that can be taken out of the two terms, that is L square over m square. So the equation remained as L square over m square into du over d theta whole square plus u square bracket close is equal to 2 into e minus v over m square. Now to make it the exact equation, we have to further work out. Here I give you a few seconds to understand and note the steps. Now to solve that equation, for the end result we multiply with m square over L square on the left hand side, and on the right hand side we have the equation du over d theta whole square plus u square is equal to 2 into e minus v over m into m square over L square, cancelling m with m on the right hand side. The equation is left as du over d theta whole square plus u square is equal to 2m into e minus v over L square. Here you from the result in equation 13, you can see that the desired equation to be solved is exactly solved as asked. The both results are same and the equation is derived from the central force of field from the equation of motion for the central force. This equation 13 is the required equation or expression for the equation of motion. From here you can go through all the steps previously told you. I give you some time to understand and go through the whole equation to solve from the first step to the end step, so that if there is any difficulty you can ask me. Hopefully till here you have understood all the steps and there is no difficulty in understanding. Now moving to the end of the lecture. If there is any difficulty, you can get help with some of the references mentioned here, or you can directly ask me. Here are some references. Your book recommended is of Goldstein, Classical Mechanics. Another book for the help is Analytical Mechanics, and Classical Dynamics of Particles and Systems for the understanding of the systems and the particles. And the other last reference here is written of Classical Mechanics by John R. Taylor. All the references are according to the outline you are studying for the classical mechanics. Hopefully there is not any difficulty in understanding the topic. Even then, if there is any difficulty, you can ask me. Thank you. Thank you so much to, for this lecture. If there is any difficulty, you can ask me or go through all the steps step by step to understand the whole lecture.